I want to welcome you all. I hope you had a great lunch. And my task will be a little bit difficult because after lunch the attention span is suffering, let's say. But the topic for today is branching strategies. And I want to ask you first, how many of you are developers in the room, like actively writing code? It's like about 80% of the room. And is there in the room somebody doing management stuff outside the code bases? A couple of people, yeah. Do we have any other roles like testers or project managers, DevOps people? No, just developers mostly. Okay, one tester here in the front row. So. Let me introduce a little bit myself, and then I'll show you what we're going to talk about. So, my name is Georgiana Gligor. I come from Romania, and for the past 13 years, I've been actively coding, even if I went from a simple developer to more experienced roles. I'm still hands-on developing, so coordinating a team or doing TDD also involves me coding. I never leave that. It's why I'm still in IT after so many years, because otherwise I would have just left. My passion is to craft LAMP enterprise applications. For me, that challenge is more important than others, because that's where the money is coming from. I can do toys, I can play a lot, but what I think it's important is to solve business problems. And currently, I'm, let's say, an application architect, and I promote PHP as the language to do very, very complicated things, even if there are a lot of other opportunities out there and options. In Romania, I'm organizing the PHP meetup, local one, and because I wasn't doing a lot of things, right, having a baby and all that, I also decided to start a PhD, and I'm trying to combine machine learning with project management so that we can help project managers actually automate part of the mundane tasks and focus on whatever they want to do. If you're curious or want to grab some fresh ideas, feel free to contact me after this talk. Now let's get back to business. And first I want to start with a very small story. These are the students of my husband, who's an archaeologist, and his job is to go and dig in certain areas of the town. So whenever you want to build like a house in our neighborhoods, Romans have conquered our town a long time ago, and there are even remains from previous periods. So you cannot just build a house, you have to first do archaeological discharge, it's called. So these guys go in and say this is the perimeter of your future house, and they want to ensure no remains are still there after you start building. And why I think this is interesting, it's because when they start digging, they never know what they're going to find out. There are some places where, imagine it's like 1 square kilometer, and if you dig in one place, you will find a lot of things, and if you dig 200 meters further, you will find nothing. So it's very complicated from the point of view of finding unexpected things or not finding them. For me, it was when I understood that this is a very good parallel with what to do with the software. Then I completely understood why we cannot have estimates, why we cannot do a lot of things, because it's just like in archaeology. Unless you do it, there's no way for you to tell. So you can only tell after the fact. So In our cases, when customers comes in and has a certain request to have like a legacy code base that you get to work on, it's mostly archaeological procedures because when you get to the very fine details, these guys are using like a brush and they have to clean it really thoroughly and leave the final product in this state. Now, for the purpose of this talk, um, when I delivered it previously, there was some misunderstanding, so I thought to add in a slide what are we not going to talk about. So if you wanted to learn everything about how to use Git in the command line on a daily basis, I'm sorry to disappoint you. It's not going to be in today's talk. Mm, we're not going to magically discover 1 hour later a magic bullet and say, okay, this is how you should do things. And of course, solving conflicts is mostly a thing in previous tasks like SVN had, CVS had a lot of conflicts, but also we get them in Git. We're not going to look at that either. And most of all, we're not going to devise a recipe. So not find a magic bullet, but also not find a recipe. You follow these 5 steps and all of a sudden you're a Git expert. That's impossible because we're working with people in teams. So everything has to be catered for at this level. So I find it interesting to explain what we do with Git and with branching by introducing the notion of change management. So when we write software, what we do is introduce changes on an incremental basis. And it's up to us to devise the correct strategy to introduce those changes and decide their size, in fact. So if you want to get started reading about change management, there's an excellent book. It's a list of essays, so they're not very long. They're a little bit scientific, so they have like proof behind everything that they do. I happen to find it in an airport, but I love it. It's an excellent book, so I totally recommend it. Now, once we know what we're not going to talk about, so what are our goals for today, the first one is to devise a framework that will help us make informed decisions. So it's our responsibility to take the decisions. So what we're going to talk about is only the key elements that compose this framework. It's just like learning a PHP framework, if you want. We will look at where the money problems are because in most software projects, teams or companies, the main problem is money. Where is your money going into? And you want to reduce that. And of course, some items to get you started of if you want to get further help, other than contacting me on every channel that you have available, and I'm happy to help. I want to show you some places where you can look. Now, a small introduction about version control systems. This is a survey from Stack Overflow last year, and they asked more than 16,000 people what are you using on a daily basis to version your work. And you see a very large percentage said Git, but they were allowed to pick multiple answers, so the numbers don't add up, right? Some people were using Git and SVN or other, or so there were combinations. What I find very disturbing in this slide is the percentage of the people who don't use source control at all. And this is like 2016, right? It doesn't look very nice. So there are a lot of people who are just doing it and maybe it works, but they're not even using version control. So if they aren't, maybe their file system looks like this, right? I do like the final, and then I at some point I just start putting numbers in there and say, okay, whatever, today, yesterday, tomorrow, and it's a horrible, but it works. So when you prepare a presentation, for example, right, it's a small project and you get all sorts of assets, you just make a safe copy and then work on the safe copy and so on. So it can also happen to people who normally use Git. So have you ever worked with any of these tools? I mean, I'm quite old, let's say, but I'm sure I'm not the oldest one. So CVS was where I started, and there were so many problems in all of these systems that you can't even imagine. The biggest problem was the fact that it was very painful to start a new branch. So you had to work like with a very small number of actual branches. But at some point in 2005, a lot of people started to work on distributed version control systems, and this is just one of them. Maybe you know him. He wrote a lot of other very clever things. And the story goes like this. They were using a proprietary version control system that was working perfectly for them. It was distributed, but in the terms and conditions, somebody said you shouldn't reverse engineer it and find out how we did it. And because they were working on the Linux kernel, right? Somebody in the team did exactly that and broke the terms and conditions. And what happened was that Linus, who you know is like a very energetic guy, was in the position to be in the middle between this developer and the guys with the tool. So imagine Linux being a mediator. It's a little bit complicated. So his solution to mediation was to go home and start writing Git. And he came back next Monday with the first version of Git. So that's how it was born. But they mostly use, even today, some of the environment around the Linux kernel is to come with patches and turbos and everything, unless you get into the inner circle and you are allowed to make commits. So Git started already from a very good base. They had to solve a very complex problem, a large-scale one, where a lot of developers were spread, and they had to be able to work with people from all over the world. Okay, so the division of items in the presentation is, first we'll have a look at the stakeholders. Who is interested in the code base? Who has a look at it? Then we'll look at some theoretical concepts. I will promise to go very fast because it shouldn't be boring. And then we'll look at how the concepts are merging together and form strategies, what people use, so that we know what to choose. And if time allows, maybe we'll answer questions. Okay, stakeholders. Most of the room is developers, right? In here we said about 80%. So when you want to write code, you're working on new features or modifying existing code, but the thing is, you want to immerse yourself in the code base and just let alone working. And this is all nice and fine, but how will your Git history look like? It's like you make a change and then you immediately commit so that you have it as a reference point, and then work on another thing, small one. If you do TDD or BDD or whatever, these checkpoint commits will be more frequent and smaller. If you use a different method of writing code, you will still have checkpoint commits, but they will be spread over time a little bit more, right? But everything in your head is linear because you want to immerse yourself in the problem, evolve over a solution, iterate, and then at some point say, I'm done. And then you just want to take your hands away and go and solve another problem. The thing is, there are other people who have to come after you and pick whatever you put there and say, okay, let's check it, let's verify that it works. And most of the time, this is dedicated people, but you can also be, it can be yourself when you do behavior-driven development and just sort out the use cases and run through them and write specific code that implements those ones. Now, what is in your mind when you want to test things, right? You may have like a mainline branch where everything production is, but you will have like a feature branch for feature A, another one for feature B, and so on. And if you have like bug fixes, they will probably live on another branch because branching is not expensive. So when you look at any of those branches, what do you care about as a tester? So try to put yourself in the shoes of a tester, and you think, okay, I don't care how it got to this point. I care about the point. This is the point. It's working or it's not working. And I have to test it, right? So if in feature A you have like 100 commits, checkpoint commits of a developer or of a team, for a tester, that's not important. What's important is the current state of the code base for that particular feature. And we will see next, this is a green light. It is good enough to go in the main line. It passes the tests, right? The next row is the package builder. So you do have your code in Git. If you're unlucky, you have 10 repositories that are related to the same project because everything is atomic. If you're lucky and have transitioned to a mono repo, then you have like one bigger code base and everybody's working on that. It comes with a lot of advantages and a lot of disadvantages, of course. But what you're trying to do is put together the functionality, the code, the dependencies, right? You just do a composer install, or in JavaScript you do npm install or whatever, and then you stick the application configuration on top of it, right? So this produces a package that can go to the server and be installed there. Now, in terms of the history, of the Git history, you only care about a hash. You don't care if it's on a branch, if it's on the main line, if it's on the bug fix branch. It's not important. When you want to build the package and install it somewhere to be in production or to be automation tested or to be performance tested or whatever, building a package only relates to one single commit, wherever that commit might live. And in the beginning, yes, you will probably have packages stuck together with bash commands, and if you evolve to a much nicer packaging system, the package will look different, but the baseline remains that when you the code is only like a fraction of it, because then you have the dependencies and the configuration. The next role is the deploy role. Mostly this is the Jenkins job or whatever other tool you might be using, but the deployer also plays a very important part in this, because the deployer will just take a package that was produced before from a individual commit, and it will not matter whatever you have in Git. It's just in development. It will not be relevant to the deploy. The deploy just takes a package. It may be a Debian package or an RPM. If you have like a very good DevOps team, they will package the code that way, or might be just a tarball that you unpack on the server. So this guy has no clue about the version control system. And the integrator, this is a role that's very, very often neglected. People forget about this, but it takes a lot of time. So what it does code review, it does code integration, and runs other checks with the help of an automated tool. So the integrator doesn't care about the commits themselves. He cares about the possibility of integrating two different branches together and validating that the final merge of these two branches is still valid and has the functionality. So this is the only part where you have like conflicts that need to be solved. And of course, you have the, this might be yourself even, when you're trying to track a problem, you're in bug hunting mindset. And this is where I wanted to take you, to see all these different roles and then come back to the developer who is chasing a problem. Because you not only have to reproduce it, like in a safe environment, you also have to detect the cause. And in here, if you look at the on the release branch, right, you've put the code in production. Let's say from the main line, you did the release branch, and you have a problem right here, and you want to know exactly when this was introduced. So I replicate it. I might be able to fix it, but I might be able to break something. So I want to know exactly what feature or bug fix introduced the problem that I have over here. And this is the most difficult thing. If on feature A you will have like 200 commits and you isolate one commit that will just say work in progress, you will be quite unlucky, and you might be able to fix the problem here by making another commit that fixes it. But now you're unsure of the state that the entire feature has. So you cannot just ditch, I want to take the entire feature out of my code base, because this has a long history, right? And then, of course, the final role would be like the project manager. Um, I've never worked in a team without a project manager. Has anyone here worked without such a role in the team? Somebody who does, who focuses on whatever is on production. This is a non-technical person, right? And whatever is in production is in one place. So they don't know about branches. They don't have this language. And then they care what's coming up, right? We are a little bit ahead of what's in production. And then the team is working on some features. If we are in a sprint, maybe you have people working on different user stories or whatever methodology you have. Now, the thing with the project manager is they want to know each of these features, the status of it individually. So if you worked for 2 days or 2 hours, they don't care. And if you have like one commit or you have 100 checkpoint commits, for them the only important thing is the final state. Is it working or not? Just like for the tester. But there is something additional. All of the project managers I worked with have this very strange request. I want to know if feature A and B play together well. If all of them can play together well, because then I will be able to put them on the coming up branch or package, right? But if these two play well together and this one doesn't, because the developer decided to change the library that communicates with an API, and introduces a change that is only visible when combined with the other two, then the project manager wants to know that information. And that information can only come by combining the histories of these features. So the more clumsy the history of one feature looks like, the more difficult it will be to identify the problem and take it out. And now that we know all the people and automated tools that look at our code bases, let's discuss a little bit the theoretical part that is a bit more dry. So concepts. Master is called in Git, but if you use something different, it might be called trunk in SVN or other ones. So this is like every time you create a completely new repository is the default branch, right? So you must have heard about it. Public versus local branches. What's important here is to know that you can have branches that live on your computer and that you can make changes to without publishing them immediately. Why was this distinction needed in previous tools? So before we had distributed version control, we didn't have this public versus local. Everything was public, and all the commits were being handled by a centralized repository. But now, because we can have branches locally, we can alter them, right? This is the PHP source that you can find on GitHub, and I want to illustrate with this picture the difference between branches that are long-lived and the ones that are ephemeral. So ephemeral is something that I can throw away, right? I make it, I use it, and then when it's integrated back, I should just delete it. For the PHP source code, it's very important to have it there because people learn from looking at the code. So I totally understand why they haven't been removed, but you see how many commits they are behind, because a branch that's updated 7 years ago is probably a lot of commits behind. So pick your battles wisely. Know when you create a branch if it will be long-lived or ephemeral, and make a good balance between them. So you see in here, for example, GitHub has this possibility to run tests on a branch, so you know beforehand if it will be integrated or not. So the trick here is that these should be the only long-lived branches in your repository, the ones that you really care about, future releases and so on. But mm, everything else should just not be there if possible. So once you used it, you throw it away. So let's look at an example, a topic branch. You might have heard people talking about topics instead of features, right? So a topic is a branch that you create with a certain purpose in mind, and look at it as an ephemeral branch. So you will throw it away. Once you have the functionality in the main line, you shouldn't keep on collecting those branches. So if you, for example, want to implement authentication, you might have like a number saying this is the ticket or whatever. You want to have like a reference and then say what's it about. And you make like one commit with implementing the Facebook authorization, right? So if you, as a developer, you make like 3 or 5 checkpoint commits, it should still be visible as one commit. So take your time, work locally, squash all those intermediate commits into one meaningful commit that will be relevant in the project's history. Because then when you get this topic branch back in the main line, you just want to see that one thing happened and then another thing happened over here. And now let's have a look at the merge workflow. So while you are happily working on this authentication branch, a lot of other things are going on, right, in the team. So maybe the designer decided to change the logo because it wasn't, I don't know, pixel perfect in iPhone or whatever reason, and it came from another branch and landed on master. So the merge workflow, when you merge all the changes in the master branch onto your topic branch, this will create an additional commit on your branch. So it will be like, I was working on Facebook authorization, then on Twitter authorization, and then, oh my god, then this logo changed, and then I make another change, and so on. This is very good to start with, so if you're using it this way, it will help you create a history, but for projects that are a lot of years old, the history might look just like this. So this is not really a meaningful commit, right? Because it's artificially created. And if you see here, I'm chasing for a bug, right? Bug hunter mindset. What happened? Oh, people were merging other branches. Okay, but my problem is to find other things, not to see this merge. So it might be very painful for somebody who needs to really dig and take the brush and find exactly what they look for in the history. So that's why people are slowly but steadily switching to a REBASE workflow. I can't recommend it enough. Just spend one day fighting it and then you will love it, I promise. The thing is, if this change happens on master and you have your 2 commits, if you use REBASE on your same branch, what Git will do is say, okay, this is master, and it will apply these 2 commits on top of master. So they will be created historically after the change in master. Why is it, and these 2 will be deleted. Why is it important? It's because your work is not in a stable state yet. So if you merge it and you do like these 2 and then this one and then another functionality, it will be a log of your work as a developer, but it will not be a log of real functionality that happened on the project. Another very theoretical concept, is the stable trunk. So trunk, as I said, it's coming from the SVN world. We call it master in Git, but if you read a little bit of literature, let's say, it will be referred to as a stable trunk. So that's why I'm making this distinction. So no, what's the catch here? Master is always considered as a stable branch, and you can release from it. So any commit that you find on master can go into production. So this is the stable trunk approach. Now you have the unstable trunk approach that some people take, and this means yes, you can take your work, integrate it into the main line, but I cannot guarantee this is releasable. So I have to package and test it and whatever other steps. So please give me a release branch as a project manager. I want to have an integration place where I can make changes, because in IE7 it wasn't working. I didn't discover until it was merged, right? So all the releases are happening from this secondary branch. This is just one approach, right? Theory. It's not an advice to use this or that. If you only remember one thing from this presentation, one thing only, look at this slide, and I will try to explain why I want you to remember this very powerful concept, the integration pipeline. We said a lot of things about ephemeral branches, and they are recommended because they are cheap and you can throw them away, right? The integration pipeline is the power to create an ephemeral branch that is called integration that helps you do a test drive. I'm merging these two topics, 1 and 2, into one branch that I'm willing to throw away just to know, will there be conflicts in the code base when I do this merge? I want to build a package from this branch, be able to install, deploy everything, and say yes or no. But this, think of it as an ephemeral branch, because this is just a replay. You're training to get your code assembled in a way that is meaningful to you. So if topic 1 has a problem, and or the business may just decide, I don't want it in this release, please hold it, right? If this was a release branch, or if I got topic 1 all the way here to the master, how do I take it out? I can't. So I just play with integrating everything that's needed into one branch, and when the decision maker says, okay, go for it, I have trained to do this. So it's cheap and inexpensive for me. Okay, so how do all these ideas combine into a daily workflow? Well, there are people who are lone wolves or are very attached to their project and are working alone. It's unfeasible. So it might happen if you have like a pet project, your entire Git commit history will look like this, because you will not create branches. It's just you working on the code base. So that was the most simple, and this one is the most complex, right? So are you using Git flow regularly? Is anyone here using it? Okay, about 25% of the people, I would say. Are you happy with it? Yes, okay, very nice. So let's explain a little bit for okay. For those who are not using it, just a quick explanation. The master is the source of truth in relation to production code. So everything that you have live is on master. And then all the crazy things are happening on develop, right? Every time you start a new release, so you have released whatever 0.1 version, and then you want to start preparing for 0.2, you merge the master into develop and start working on it directly or create feature branches, right? Now, the Git flow strategy is uses a merge workflow. So if you make like one change here and one change here, when you will merge them into develop, they will be like this. one commit from feature 1, another from feature 2, and another from feature 1, and it will be a little bit messy. That's the only problem I have with GitFlow. Just as an advice, if you use feature branches, try to work locally and squash your commits. At least come with one commit onto develop, because onto develop you will have like things that are ready to be delivered, but if the decision maker changes their mind and wants a feature out, with these commits like this, you cannot take it out. But if you come with one big commit that implements whatever feature you have, you might be able to revert it because it's all in one place and you have control. And then once things are undeveloped, they go to testing, and release branches, dedicated release branches are created from them. Things might be fixed here, or just update a README file or whatever, and then things go both to master and to develop. So the way to keep these things in sync after the initial tag, you see this line here will only happen once, from master to develop. Everything else will come from a release branch that will make sure the same code is in both places. Now, this is a very good approach and it scales for a lot of teams, but the problem is the Git history will very much look like what we saw: merge, 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 merge. And it might work or it might not work in your case. If you need to dig in the history, it might not be very good. There are very simple strategies that are used in agile teams that only have like using the stable trunk approach, right? So whatever is going to happen here in the topic, they do an explicit merge of changes, and then create a pull request, do whatever coding reviews and everything, they put it into master, and from here they will just create a release. For GitHub, it works perfectly because they are software as a service. You don't need to look at their history. They don't need to roll back. Or if they roll back, they make another topic branch that will mitigate this one. So this is specific for a certain case. Now, I found another strategy. Why is it different from the previous one? Because it uses REBASE, so it uses much cleaner history, but the only source of truth is still master, and the history is cleaner. So you can see that from here, the changes came. You can see them with an explicit merge, only this one, so you will not see this as another checkpoint commit. Now, this workflow for agile teams is using a stable trunk approach, but they want to have like a QA branch from where they do tags. Why? Because they want to be able to say, okay, this is stable, but I don't want to release it yet. So I want to have the luxury to make another change. This is still pretty simple, and the only way they chose to, the only reason they chose to have a QA environment was because they wanted to use Git directly to update the code on QA. So instead of, there's no packaging process here, right? Which you, in the Git flow, you can have packaging as much as you want because you have a separate release branch. This one is just updated from Git. Now, GitLab as a company is a competitor to GitHub, but they do one thing differently. They allow you to download an archive of their code, install it on your machine, on your server, and use it. Because they do that, so their business model is like software as a service and something that you can use back home. And for this reason, they need to employ fixed releases. So what happens here, they have like a master branch, and then they have one branch for every environment that they offer. So this is gitlab.com, but they also have a staging environment where they do frequent deploys. It's advocated that the feature branches are really, really, really tiny in all of the examples that we discussed until now. these guys have the flexibility to make a little larger changes, let's say, and they maintain releases based on the version number they want to support. So if they all of a sudden decide they don't want to support another version, let's say 1.7, very, very old, they just ditch the release branch and say whatever, forget about it. But their history will look much clumsier than one before. And this slide is trying to summarize something that doesn't fit in a slide, which is how do you get to work on the Linux kernel? So how are the big guys using it? So if you have like a geographically spread team that has different skill sets, has everything, how are these guys solving the problem? So what they do is they have like 4 main branches, right? Keep it simple, stupid. Principle, 4 main branches. The last stable release is this one, maintenance. Then they have whatever will be on the next release is the master. And this is the integration pipeline. The integration pipeline is a branch where you get to play, and if you do an integration locally, but you can just throw it away. The history of this branch will not be visible until so you don't publish the integrations in this branch unless they will go to the next release. If they are not approved, this will not be a visible commit in the public history. Now, how do people work on this? There are 2 ways. You are in the outer circle, anyone in this room, if you want to contribute a change to the Linux kernel and you're really sure about it, you can do whatever changes you want. You can use Git if you want locally, but you have to send a patch file. So you have to create like a patch file that will represent your proposed changes. And they take the patch files and put it on the proposed updates branch, see if that one breaks. If it doesn't break, so this is how they apply it. It's just a text file, right? It will go to the integration test bed and test it with even further changes, because there are a lot of items landing the next branch. But if you're in the inner circle, you've been known to the team and you have a Git account in the team, then you get to work on your branch that is visible, and your proposed change will not go here, but it will be in the integration test bed. That's the difference. So you get to work with files or with branches. And you see here that master is used to tag releases. And then once we tagged this release, we are waiting for new changes, and we move all the master items into maintenance. And whenever we want to maintain a certain version, we make another branch that will take care of that particular release. If the good thing about having these branches is that if there is a change that you only need to make in that version, you go and do it on the release branch. Does it look overly complex or overly simple to you? How do you feel about it? Would you be willing to work in a team that does this? Well, truth is, these are ways that you documented ways that assemble all the theoretical concepts that we found so far. But the trick is to not be let yourself be driven by that. So don't just okay, this is the tool, this is the rule, whatever. Don't just take it, embrace it, and fight it if it doesn't work for your team. Just try to learn the concepts and try to assemble them in a meaningful way for your project and for your team, because then you will probably gain like a lot of time. Now, there is one thing. transitioning between various strategies is quite painful, but do you know when to do it? I mean, everybody can have the courage to do it, but do you know when is it okay to say, okay, I'm using this very simple agile strategy and we need to move to Git flow, or the other way around maybe. When is are the signs? So if you see somebody in your team is constantly fighting something, and I'm not referring only to developers, that's why we had the introductory part. Is your tester, in fact, complaining out loud about the same things, that he is spending too much time in version control history? This is one sign. So anyone is DevOps, QA, and developers, of course. And then if you have a polyglot technology stack, this is a little bit problematic because everybody might want to have their own repository. And this is an entire presentation, a completely separate one, about the fact that you want to have like different repositories or one. And if you want to find out, there are two already very good presentations on the topic online. One of them is at Drupal Camp. Fabian Potencier showed how they develop Symfony and why they use a monorepo against multiple repositories, which they initially had for Symfony. But in our case, most of the time the front-end people and the DevOps people just go and do their own thing, and then they use a certain strategy, and then the backend guys use another strategy, and then somebody has to release all the code, and it will be like this. So just look. This is a danger sign. It's not a bad thing. Just look if you do that. Another thing that I noticed is very problematic is if you're geographically distributed in such a way that you work across too many time zones. So then instead of being able to discuss with the team, you discuss in code. So you put everything very verbose in history instead of trying to make those atomic changes that we discussed about. And if production bugs pile up, which happened in one of the projects I was working on, we were using Git flow, and we were having constant problems about merging some Drupal changes with the Symfony API and all that crazy thing. This was one sign that Git flow wasn't working for us. And I am still an advocate of Git flow, but for that particular project team and other things, it wasn't working. And this is how we found out when we started digging in the production bugs. There were most of them were generated by the way we were working. And if you make changes to a team, if you add more senior people, they will be much easier onboarded with different changes. But if you add juniors, they will have a little bit of trouble working, for example, with Git REBASE or squashing their commits. So you have to balance all the things and pick the right strategy, also depending on these things. We have a couple of minutes for questions, and I want to take advantage of it. Any question?